and we're going to keep looking at equations, but in a little bit of a different way. We're going to talk about how we can take patterns and translate them into equations. And we're also going to show pictures of equations as in graph them. So the first thing we're going to do is talk about patterns. So here's an example. You're at a wedding reception. The tables and chairs can be set up in the pattern as shown. So, you should be able to see from the pattern here, how many people can sit at one table? 4. 2. 3. Without seeing a picture of it, what do you think 4 would be? Why? So you see the pattern here, vertical pattern. We keep, every time we add a table, we can add 2 people. Okay. However, what if we put 25 tables together?
No, never mind.
Okay. It's a little bit harder, right? I mean, you could follow the pattern, but that's not very efficient. Because you have to keep going, okay, 4, there's 10, 5, there's 12, 6, there's 14, all the way up to 25. That's not very efficient. What we want to do is we want to find a pattern or an equation that goes horizontally. What can I do to the, what kind of math can I do to the number 1 to make it 4? And then do the same math to number 2 and make it 6. Okay? Not yet, not yet. Okay? So doing that means we're going to develop an equation. So that if you plug in the number of tables, you can calculate the number of people. Okay? So let's say we put this information in a table. So we had 1 table, 4 people, 2, 6, 3, 8, 4, 10, 5, 12. Okay. Like I said, we can see a vertical pattern. Every time this goes up by 1, the number of people go up by 2, but that's not efficient. I want a horizontal pattern. In other words, I want an equation so that if I know what T is, tables, I can calculate P, people. Want to give it a shot? Okay. How'd you get that? You're right. Okay, any reason why you came up with ×2? Or were you just sort of playing with the numbers a little bit? That's fine. Yeah, that's fine. That'll work too. Okay. Yeah. But there is a way that we can get ×2. If you look, every time we increase the number of tables, the number of people goes up by 2. That implies in our equation, that means in our equation should have a ×2 in it. So I'm going to take all of these and ×2. However, when I ×2, I always end up 2 short, don't I? 1 times 2 is 2, I'm 2 short. 2 times 2 is 4, I'm 2 short. So to finish the equation, I have to add 2. So there is, besides just sort of playing with the numbers, you can sort of do a little bit of logic to it. So here, what do we notice? Okay. Every time we add a table, we add 2 people. This suggests in our equation that we should multiply by 2. So like if you saw a pattern going down, add 4 every time, then in your equation, you should have a times 4. Right? If you're adding 10 every time, in your equation, you should have a times 10. But that's not the entire equation. However, when we do this, we are always short by 2. This means we should also add 2 in our equation. Okay. So that's how we can develop the equation in a sort of logical manner. So therefore, our equation is going to look like this. To find the number of people, we take the number of tables times 2 plus 2. However, I don't want to have to write all that out all the time. That's what algebra is for. Instead of number of people, what did we call it in the table? P equals T times 2, but how do we write that in algebra? 2T plus 2. And that's what our equation looks like. So going back to that original question, how many people at 25 tables? 52. So 25 tables, P equals 2 times 25. Notice I substitute in parentheses, plus 2, which means 52 people. Okay. You don't have to write these down, but before we move on, can you tell me the equation? Okay, just 1 second. Give everybody a chance to take a shot at it. What do I do to X to get to Y? So in other words, Y equals, what do I do to X? Okay, Finley. 5X plus 1. Because I'm adding 5 to Y every time, that means times 5. When I go 1 times 5, I'm 1 short. 2 times 5, I'm 1 short. So I have to add 1 to my equation. So it's 5x plus 1. Okay? One more before we move on. Again, what am I adding every time? How much? Okay, so that's part of the equation. So I'm adding 3 every time. However, 1 times 3 is 3. How do I get from 3 to -7? How much? Yeah, I'm going to have to subtract, aren't I? How much do I subtract 3 by to get to -7? Not quite. 10. So y is going to equal 3 times x minus 10. I like these, they're kind of like puzzles. Okay, let's look at the last couple of examples. This one's a little challenging. An airplane is cruising at a height of 10,000 meters, so that's where it starts. And then it descends, goes down to land. The table to the right shows the height of the plane every minute it begins going down. And it changes at a constant rate. So at 0 time, it's 10,000 meters. After 1 minute, it's down to 9,700, and so on. I want to write an equation. How do I calculate h? What do I need to do to t? This is a bit of a challenging one. What's happening every time here? It's going down by 300. So my equation needs minus 300 in it. Where do I start? Like, where does it, what height altitude does it start at? 10,000. So 10,000. And then I lose 300 every minute. So minus 300t. Notice that's a little different equation than what we were looking at before. So if you see an equation where it's going down like that, start with your highest value and then start subtracting how much it's going down by every time. Yep. If this said capital T, but these say lowercase. Follow what it says in the question. Unless you're deeply offended by lowercase t's. You okay? So now that we got the equation, you can answer questions. How do I calculate the height after 15 minutes? What would you do? Plug 15 in for what? Minus 300 times 15. Right? Because that means times. So that would be 10,000 minus, did anybody get this? Anybody? Anybody? Thank you. And that will give us 5,500. So after 15 minutes, it'll be at 5,500. You could be also asked a question like C. Notice this time, we're asked to find t because it says how long. How long after beginning its descent will it land? Well, when the plane lands, what's the height of the plane? 0. So that tells us h is 0 and t is what we're trying to find. So I have to plug in 0 equals 10,000 minus 300t. What did I just create? An equation. And you guys have been solving a lot of these. So we have to solve. We got to get t by itself. What's the first thing I do? Sure, I could add 300 to both sides. I could have subtracted 10,000 and then divided both by negative. Sure, let's do that. Add 300 t. Yeah. That's 0. That's the number 0. With the height of the plane when it's on the ground is nothing. Right. Correct. So I get 300t is equal to 10,000. Then I'm going to divide 300. Divide 300. That's going to give me a decimal.
It's repeated.
Yeah. So we could go, let's go to 1 decimal place. 33.3. Which is about right, because usually when the captain comes on and says we began our descent, it's usually about half an hour until you're on the ground. Any questions about this? Okay, the last example, we're not given a table, we're just given a sentence. Can we figure out the equation from the sentence? Which you should be able to, because this is kind of like what we did with the problem solving. I was told the cost of a cab ride, I have to pay a fixed cost of $3.60. So I have to pay that no matter how far I go. And I have to pay $1.50 for every kilometer I ride in the taxi. How can I convert that to an equation?
360, well, 3.6, 1.0 times 3.
Right. Will get me the cost. Here, we'll go capital C this time. Or you could have put the C at the beginning. C equals, either one is fine. So that's the equation. And now you're asked to use this to answer part B. Well, you're told 11 kilometers, so you plug in 11 here and calculate. So $3.60 plus 1.50 times 11 is going to get me my cost of the cab ride. And that's going to give me, I'm going to cheat a little bit here, 3.60 plus 16.50, which gives us 19, which gives us $20.10. I think. Yeah, $12.10. That's the cost. A lot of what we do in mathematics is we take patterns that occur in real life and translate them into equations, because then we can make calculations with them, or we can solve for unknowns with them. Okay. Okay.